This is lesson 5-6, Formalizing Relations and Functions. Here's some vocabulary for this lesson. Some of this vocabulary is new, and some of this will be review. A relation is a pairing of two sets of numbers. The numbers in a relation come from the independent variable and the dependent variable. Typically, the independent variable are x values and the dependent variable are y values. The set of values that come from the independent variable is called the domain. The set of values that comes from the dependent variable is called the range. These are two key terms that will be used throughout the rest of the Algebra 1 course. A relation is a function if and only if each domain value, or x value, has one and only one range value, or y value. Later on in this lesson, we will show you two ways to test to see if a relation is a function. Here is testing for a function. There are two ways. The first thing you can do is map ordered pairs. The first thing you want to do is set up a two-column table, identify your domain and range, and then draw arrows to match up values from the ordered pairs. If more than one arrow is drawn from any independent value, or domain, the relation is not a function. The other way to test for a function is doing what's called the vertical line test. The first thing you need to do is plot all points and connect the dots if the relation is continuous. Second, then you want to draw as many vertical lines, lines that go straight up and down, that you can on the graph. If any of your vertical lines pass through the graph more than once, the relation is not a function. Let's take a look at some examples. First, on the left, we have a set of ordered pairs. Let's do the mapping of ordered pairs to test and see if it's a function. So the first thing I do is set up a two-column table. I put my x values on the left and my y values on the right. Then I draw arrows. 3 matches up with 6, 5 matches up with 7, 7 also matches up with 7, and 8 matches up with 9. This is why we call it mapping. We're taking x values and putting an arrow to the y values that it's associated with. Since all of the x values only have one arrow going from them, this relation is a function. Let's take a look at the example on the right and use the vertical line test. So we have a graph and we want to see if it's a function. So what we do is we draw as many vertical lines as we possibly can. As you can see, all of the vertical lines only go through the graph once, if at all. Therefore, this is a function because no line touches the graph more than once. Function notation is a little bit different than what you've been used to in middle school. Function notation will replace the notation that you've been used to. You are most likely used to seeing things like y equals 3x minus 1. Instead of using y, we'll use something different. We call this f of x. The key part here is to realize that this is not f times x, even though we're using parentheses. This is pronounced as f of x, or function of x. Your new notation would look like this. The only thing you're doing differently is you're not putting y, and you're putting f of x. Let's talk about evaluating a function. To evaluate a function, you want to read the question carefully and replace any given value for either x or f of x, depending on what's in the problem. Here's an example. The function f of x equals 250x represents the number of words, f of x, that you can read in x minutes. How many words can you read in 8 minutes? Anywhere where you see an x, you'll replace it with an 8. So, x represents minutes, so let's replace x with 8. That means f of 8 is equal to 250 times 8. So f of 8 is equal to 2,000. Your conclusion statement is, therefore, you can read 2,000 words in 8 minutes. This is the end of day 1 for this particular lesson. Please pause the notes and do the homework assignment that's prescribed in class. This is the beginning of day 2, finding the range of a function given its domain. The first thing you want to do is plug in the values of the given domain into your function. Next, write all of your values of the range in set notation, which is curly braces. Here's an example. F of x is equal to negative 3x plus 2, and I'm given the domain negative 2, negative 1, 0, 1, and 2. I now need to find the range. In other words, I want to take all of the values in the set and plug them in for x. So f of negative 2, when I plug in negative 2 for x, is equal to 8. F of negative 1, after doing the arithmetic, is 5. F of 0 is 2. F of 1 is negative 1. And f of 2 is negative 4. So my final answer here is I want to put it in curly braces, and I want to go from least to greatest, saying that it's negative 4, negative 1, 2, 5, and 8. That is my range, all of my y values, or my f of x values. Let's talk about how to find a reasonable domain and range. A reasonable domain and range is found by reading the problem given and, quite frankly, using common sense. Here's an example. A gardener wants to place a new square garden. The function a of x equals x squared represents the area, a of x, in square feet, that the gardener can plan based on the length of the space, x feet. The maximum area he's allowed to have is 64 square feet. Because we're speaking of an area, negative numbers and 0 are just not possible. Decimals are possible, and it is best to write this in set builder form notation. Because the maximum area is 64, the length cannot go beyond the square root of 64, which is 8. So therefore, our domain is going to be all the x values such that 0 is the lowest value that's not included, and 8 is the highest value that we can include. When we do the range, all we have to do is plug in all the domain values into the function. But since this is such a large domain, it's advised that we'll use set builder notation again. So therefore, my range is between 0 and 64, 64 being included, but not 0. If you're having issues with this lesson, please consult your teacher in class.